Good morning, class. Today we're going to be introducing momentum. Now, on yesterday's question, a lot of people responded about what they thought momentum is and what it relates to. And you know what? I'm very impressed. You guys all have some very good answers at describing what is momentum and how it relates. And some people made some very excellent examples that demonstrated what momentum was. Let's go ahead and make some notes for anyone who feels like they might have been left a little bit behind. Momentum is the quantity of motion as Newton describes it. What does that mean? It means that it's how much something is moving. And there are two key ways to really change how much stuff is moving. Momentum is a relation of both mass, so something with more mass will have more movement, and it's a relation of velocity. So if something is moving quickly, you could say it has more motion. Momentum, however, is best understood by thinking of situations. So let's imagine a game of football and see what's going to happen. Here's Steve, who is 97 kilograms, and he's running 5 meters per second to the right. And Rudy is 54 kilograms, and he's running 5 meters per second to the left. Well, when they come and collide, who do you think is going to win? Hopefully, you obviously know that Steve is winning. He has more motion overall, and the fact that he has more mass is what will allow him to overpower or to run over Rudy, because Steve has more momentum than Rudy. Now I ask, is there any way for Rudy to end up winning? Any way that doesn't involve Rudy bulking up to be super huge? Well, what if Rudy went super fast? If Rudy went super fast, that extra velocity that would allow him to overcome and overpower Steve's momentum. Hopefully the situation of tackling helps you think of momentum in terms of a real physical situation that you understand. Momentum follows a fairly simple formula. Momentum is given the variable of a lowercase p, and the momentum is equal to the mass times the velocity. Now, velocity is a vector, and momentum depends on your direction as well. So momentum here is a vector. Now, the units of momentum we can find straight from the formula. Mass has the units of kilograms, and velocity has the units of meters per second. So it's the kilogram meter per second. Another unit that you might find is that we can also call it Newton seconds. This is another unit that we have for momentum. Let's look at a couple examples going over momentum and its formula. So we have a 500-gram bouncy ball that's thrown 12 meters to the right. How much momentum does the ball have? Well, momentum follows our easy formula. Mass times velocity. The mass here is 500 grams. The velocity is 12. This should be pretty simple. But remember, everyone, watch your units. Got to turn those grams into kilograms. 0.500 kilograms times those 12 meters per second is going to be 6 kilogram meters per second. And remember, this is a vector, so we have to have the direction, which is to the right. Now, that's a good, easy problem. Let's go ahead and look at this next one. The 500-gram bouncy ball from our earlier problem, so we know it's momentum, bounces off a wall and, typo, is heading at 5 meters per second to the left. How much did the momentum change? Well, here we have to go ahead and be like, what is the change in something? Remember, change is represented by our delta, and you always can find the change by taking the final quantity and subtracting the initial quantity. So if I wanted to find my change in momentum, I would take my momentum in the final case, and I would subtract my momentum in the initial case. Now, momentum initial was easy. Momentum initial we got in our previous problem, 6 kilogram meters per second to the right. What's going to be our final momentum? Well, we could go ahead, we could take the mass times that final velocity. So our mass times our final velocity, 5, is going to be 2.5 kilogram meters per second, and the direction now is to the left. So what we have here is we have things going in different directions. How can we specify in a formula what different directions mean? Hopefully you haven't forgotten that we use plus and minus signs. For example, to the right often is a positive, and to the left is often a negative. So I'm going to make this negative 2.5 kilogram meters per second. I'm going to make this positive 6 kilogram meters per second, because to the right is positive and to the left is negative. Let's determine our change in momentum now. Our final momentum was negative 2.5 kilogram meters per second, and our initial momentum was positive 6. Negative 2.5 minus positive 6 is going to be negative 8.5 kilogram meters per second, and that negative here means that the direction of our change is to the left. Hopefully you find these problems fairly simple. This is just an introduction to momentum. We're going to be learning more about momentum in the coming week. Have a good day.